Hello, happy Friday, happy weekend, whenever you're watching this. So today we're going to be talking about friction. We left off with that last class. You guys did the lab, kind of looking at the different coefficients of friction, comparing the kinetic versus the static friction. So what you should have found in that lab was that your static friction was higher than your kinetic friction. So the reason for that is this. So friction is caused by microscopic bonds or microscopic welds that are created by intermolecular forces. So you have these two surfaces. Sometimes they're more rigid, and some of them are more rough than others. Some are smoother, but in any case, you do have momentary bonds forming between the two surfaces. So in the example like the one here on the screen in the top right with the box on the surface, here you have two surfaces that are not completely smooth, and you have a lot of surface area in order for that to create these little bonds. So those forces have to be overcome in order to cause motion. So that's why the static force is so much higher. So you have to break those bonds initially to get the object moving, and then you have to keep applying the force to keep it moving so that it doesn't form those little microscopic bonds again. So friction will exist when there's a normal force between two objects and an applied force trying to move that object. You have to have those two things. So you have to have an object sitting on a surface, touching another surface, and an applied force. Friction does not exist unless both of those things are happening. The coefficient of friction, which is a mu, so if you look here in the center, this little symbol is called a mu, yes, like the Pokemon. That's the ratio between the force of friction and the normal force. So you guys calculated that in your lab last class. So you had the force of friction that you either calculated using the mass and acceleration or that you got from the graph from the first section of that. And then you divided that by the normal force. So we knew the normal force because we knew the mass of the objects. We know gravity is 9.8. So you guys were able to calculate the force of gravity and in turn find the normal force, which is equal but opposite. So these two categories we have for friction. Kind of been describing this already with our objects. So with last class, you guys were talking about your little wooden block, but it does exist in other places in our lives. So static friction is going to occur when an object is not moving. Some examples here, you have a car parked on a hill. So the car obviously has its weight holding it down. So you do have the force of gravity holding it down. There's not necessarily an applied force, but the gravity is pulling it downward. So you could consider that your applied force in this sense. So nothing's physically pushing on it, but we do know that gravity is pulling it, and gravity would eventually pull it down the hill if friction wasn't keeping it still. The other example here is a man leaning up against a desk. So the amount of force he's applying to the desk is not enough to overcome the static friction. Otherwise, the desk would slide out from under him and he would fall down. On the other side, we do have kinetic friction. So this is going to happen when an object is moving. Generally, about half of a static friction is what we should find here. So once the object already is moving, it should be easier to keep it moving than it was to start it moving. Some examples of just pushing things around, rubbing your hands together. You obviously get some heat when you do that. All examples of friction. So we know that friction opposes your applied force. So if I am pulling my wooden block to the left, friction is going opposite of that towards the right. So static friction will be noted as a capital F for friction and then a subscript of S. It's going to be the resistive force that keeps the object at rest. So this should always be greater than your kinetic friction. Kinetic friction is going to be F of K. This can be a resistive force once the object is already in motion, and it's going to be less than static friction. So you can see in this graph over on the side, this is very similar to the results you got in your lab last class. So that in any case, no matter what the coefficient of friction is, you will always have static friction being just a little bit higher or up to twice as high as kinetic friction. So the force of friction is going to be proportional to the normal force, which we talked about a little bit earlier with this coefficient of friction. So this mu that stands for coefficient of friction. Coefficient of friction has no unit on it, so it's just going to be a number value. So whenever you're calculating this, it's always going to be your force of friction divided by your normal force. So that means that the size of your forces, the larger contact areas together will affect your force of friction. The mass of the object will affect your force of friction. So all of these things, the type of surface that it is, so if it is like rubber versus ice or something like that, all of those things can affect friction. So the adhesion between your surfaces, we already know, are tiny little bonds being created. So you're overcoming them.